Hello and welcome to 5-Minute Math. Today we are looking at lessons learned from the 2023 Algebra 1 STAAR test. Specifically, we're going to take a look at readiness standards that had less than 50% mastery across the state and see if we can figure out how that might affect our instruction for this coming year. So let's start with the most difficult readiness standard. This is 8.11b, simplifying numeric and algebraic expressions, specifically laws of exponents. And we see here on number 10, we've only got 38% here. And the issue really is we're taking the power of a power, but what if one of those powers is a fraction? Really, this is what we're asking them to do. We're asking them to multiply 3/7 times 2 because our mathematics reference materials let us know that the power of a power means you multiply them. But what does this mean? Does this mean that you multiply 2 by both, right? Because you've got 6/14 as an option. Or, the correct answer here, you multiply 2 times just the numerator, right? But even that little trick is going to be a difficult answer for some students to find, and only 38% of the students were able to identify that correctly. Now, this second one, number 35, this was drag and drop. This was extremely difficult. We had only 4%, only 4 out of every 100 children got both of these correct. Both of these were 4. If you work this out right here, you see extremely difficult because we're dividing, right? But this is what it ends up looking like when you divide, right? You divide by, if you just do it straight like that, now you've got a fraction within a fraction. So what happens here? So students might be unfamiliar with, multiplying by the reciprocal, right, by making it look like this, right? If you did it like this, it's a little bit easier to manage, right? Taking your y, since it's in the denominator, right, making it the -1, right? Now we can handle that with just basic subtraction rules, but those are the two most difficult problems for 8.11b, 21% overall mastery. So what did we learn about that? Fractions definitely add a layer of complexity when we're dividing exponents or finding the power of a power. So if we're just practicing with whole numbers, we're not going to prepare our students. It's this drag and drop response required you to use the same number twice, and not all problems allow that. Sometimes drag and drop answer selections can only be used for one of the responses, but this time we had to use the number 4 twice, so that's what made it difficult. So what our instructional implications are, these are going to be down here in these white bullet points. So we need to utilize fractions more when asking students to multiply or divide by exponents. Just increase the complexity. Have them very comfortable with having a fraction in the denominator and how to deal with that. We need to bundle multiple laws of exponents into a single problem, like radicals and division. Don't just have pure, multiplying exponents or dividing exponents or taking the power of a power. Have them multiply and take the power of power, and maybe have a radical in there as well. And then this is what I was talking about, right? How do we deal with this 6/4 divided by 6 to the half to the second power, right? That's the same thing as this right here. And if you rewrite that, that becomes a little bit more flexible, gives you some more flexibility if they're comfortable using negative exponents. So the second most, or actually tied for the second most, is going to be 8.7c. It was only tested once, 30% overall mastery. Parent functions, right? We're looking at parent functions and child functions. And, we've got our basic vanilla graph right here, f of x equals x squared. But take a look at what we're doing. We're needing to find both a horizontal change and a vertical change at once. We do drag and drop, and we need to find just the coordinates of our vertex here. And what we see here, right, is the -3, right? That's going to actually move. That's the tricky part. When it's in there, it's actually going to move it to the right. And then the -9, that's going to move it down. So that's kind of a little counterintuitive there. So only 30% got full credit, but if you count both of these, right, this is 2 points, this is 1 point. We had at least 65% of the students get at least 1 point. And most likely I'm thinking it's this 3 right here really messing us up. A lot of kids thinking it's -3. So what did we learn? Well, the drag and drop removes certainty for partial guesses. So if they're trying to figure out, well, I know what the -9 is going to be, the y, having it as a drag and drop increased the complexity because there's no A, B, C, D to choose from. And they had to analyze both vertical and horizontal transformations simultaneously. So that added a layer of complexity here. And then, as I kind of pointed out here, this -3 actually moves the vertex to the right. That's kind of something counterintuitive students need to be aware of. So what are our instructional implications? We need a bundle problem so that students have multiple transformations together, so have it move up and to the right or down and to the left, not just up and down or just left or right. And then, right, this is something that we could have done if we wanted to solve that problem. How do we graph this, right? You have your graphing calculator. How do you graph the child function correctly with the exponent, right? You could have done this, this x minus 3 squared minus 9. If you bring that exponent back, you could have graphed it, and then you could have just seen where's the vertex. So most of us are just trying to identify the change in the vertex simply by how these terms are added or removed, but we could also graph it as well. So next we have A.8a, also 30% mastery, and this is one of the lowest ones with that's not including a new item type. It's just solving quadratic equations. Obviously, we could take square roots, we can factor, we can complete the square, we can apply the quadratic formula. This looks like it's pretty vanilla right here, right? We've got ax squared plus bx plus c. Obviously big numbers, but that's fine because we've got our calculator. But take a look. Every answer choice has a simplified radical. It doesn't automatically turn into some huge but beautiful perfect square that turns into an integer. So we had to not only apply the quadratic formula if that's what we're using, but then we had to learn how to simplify these radicals here. So look at our answer selections here. This is our A, our B, our C, and our D, right? That's really indicative of just guessing, right? Now, obviously we had a little bit less here and a little bit more here, but a lot of guessing means they just took a look at it and said, yeah, probably not. So our answer selections really lets us know, or the answer distribution lets us know that a lot of kids really weren't sure how to handle that because they had to simplify the radical. There were multiple strategies that could have been used, right? The quadratic formula is probably one that we want them to focus on because it's complicated, but it's a very strict algorithm that they could use. Here's the thing that we can focus on for our instructional implications. Make sure your problems don't always have, a really huge, when you get into your plus or minus, all that business, right? Make sure it doesn't end up being something, nice and neat like 100 once you subtract. Okay, because then that's going to make it way too simple because you can just turn that into 10, obviously. So make it something that you still have to simplify. And then have students, here's another instructional strategy that we can use, have them solve the same problem using at least 2 different strategies, right? Give them the flexibility. If we just focus on the quadratic formula, they might not know how to complete the square. So we want them to have some flexibility in saying that multiple strategies can be used to solve problems. All right, so we did a little bit better on A.2a, domain and range of linear functions. You would think this is pretty simple, but only 33.5% overall mastery, and you see both problems were kind of difficult. Okay, so we had a inline choice right here on number 7. So if you add, this is the 2 points, you get them both correct. 22% got 1 correct, so that's still only 55%. That's not very good. 44% got no credit, right? And if we're looking at this first one, here are our answer choices, right? So we are, the first one wants us to look at the range. First off the range, it's greater than, so we're just looking at the bottom bound, and then the second one brings up the upper bound there, less than or equal to. And you notice we've got a closed circle in the upper bound, we have an open circle in the bottom bound. So that shouldn't be super difficult, but only 33% of the students were able to get that. And then if you look over here on number 46, right, we're just, x is greater than 5, y is less than 2, and you're just finding the graph that shows that, right? It's just an abbreviated linear function here that has a stopping point. And they all have open circles, so we're not playing with greater than or less than, or greater than or equal to, less than or equal to. So let's see what was the difficulties here. On that first one, when we had the inline choice, the responses were in verbal form rather than as inequalities, right? So rather than less than 2 or greater than 2, right? They had to have it written out greater than 2. So that adds just a little bit to be able to translate their number inequalities into verbal descriptions or written form. They had to differentiate between open and closed circles, at least in the first problem, right, for greater than or equal to. And then both problems required analysis of both domain and range simultaneously. Well, the first problem just had the range, but the second one had both domain and range. So here are the instructional implications. We want to bundle problems so that they're doing that. They're assessing both domain and range together, because it's really easy to get confused. Okay, domain is going left and right, range is going up and down. That's a lot to kind of keep in your working memory if you're looking at 4 different possible answer choices like that second problem. So we need to bundle those problems together so they practice that. And then you can flip it, right? Give them something like this, right? Say, hey, here's the domain, x is greater than 2, y is less than or equal to, -5. Have them draw it. Give them graph paper. Have them draw an array that would satisfy that, so that they could they both need to be equal to, so we can have a closed sign there. But have them draw it so that they can practice the creation of that. And then this is an opportunity to provide some rich discussion material for students. Have some error analysis, right? If we wanted to go back to this one right here, right? If we know what our answer is, tell me why A, B, C, or D is incorrect. Don't just tell me which one is correct. Tell me which one is incorrect and why. What is it? Is it the domain, or is it the range that makes it incorrect? Because that error analysis just strengthens their understanding. All right, so we have one little bit better, but we're still just a hair over 1/3, right? 8.9D, 34.5% overall mastery. You see it's tested twice. Graphing exponential functions. Now, this number 9 was very difficult. First, we had to just know what the asymptote was. That's a vocabulary term we need to bring into. Most students probably are familiar with that, but you had to write the equation for it. And look at this. The answer, if you don't remember, the answer is on the asymptote. Kind of looks like this. It's right there on the x-axis. But how do we graph that? You had 14% get both points. 59% get partial credit. We don't know, but this is my inference here, is that if 60% right of us get partial credit, we know that it's a 0, but it's on the x-axis. So the correct answer, if it's on the x-axis, is y equals 0. But my inference, my supposition, is that 60% of the students put x equals 0 just because they thought it's on the x-axis, therefore I need the letter x in there. And so flipping the y and the x for that x-axis is really going to obviously take a point away from kids. We did a little bit better on number 42, 55% correct. We had to just first read a description here, and then we had to find a true statement, right? And the answer here is, the purchase was $650, so that's our y-intercept. So both problems ask students not necessarily to graph it, but to identify features, right? The asymptote, the y-intercept, and like I said, they most likely label the x-axis as x equals 0 when it should be y equals 0. That's probably where that mistake came from. So when you're working with the standard form, when we're trying to identify this, we also need to make sure that since this is the initial, right, this A is this initial right here, we also need to label it as the y-intercept. And have students explain why, because that would have helped them on that second problem. And then when given an exponential function in equation or graph form, have students create a real-world situation. So rarely do we go from this to a real-world situation. What we're doing is we're going from the real-world situation into our standard form. Have them try going from just a basic equation, try to find something, describe something that would do that, because the thing they want to identify there is that initial form, right, or that initial amount, that A amount is the y-intercept. So if they can solidify that, that would have helped them with that second problem. So we're getting a little bit better now, 39%. 8.2i was just tested once. And we've got systems of linear equations given a table of values, a graph, or verbal description. Only 39% of students were able to correctly create two different equations in standard form for line A and line B. Now, look at our answer choices, right? That's A, B, C, and D. Once again, the distribution is indicative of guessing. But look at what they had to do, and we'll come back here. They had to find the slope, right? So you have to find the slope of each of these lines. Then you have to substitute one of the coordinates, x and y, to solve for b. Then once you have your slope, once you have your b, then you had to translate it into standard form. ax plus by plus c. You had to do that for equals c. You had to do that for each of those. So it's a lot of work, and most likely, that it's a sequence of formulas, but our instructional implication here is that we need to focus on applying the correct sequence. If you do one of those three things out of order, or you're just guesstimating, the whole thing comes, tumbling down. And we need to focus on building stamina, because that's a lot of work, right? And they could have checked their answers with substitution, right? They could have graphed the discrete points along, on their graphing calculators, and then the system of equations they chose to see if they match up. There are ways to check this, but stamina here is the issue. And so some students just, after 2 or 3 minutes with it, they're kind of tired, things aren't making sense, they'll just kind of give up, and that lets us know that we're just kind of guessing right here. So those problems are ones that we probably want to call out for kids and just let them know it is going to take a little bit longer, and that there is a sequence of formulas that they're going to need. When we're looking at 8.5a, 42.5% overall mastery, we are solving linear equations. The issue was not the second one. Look at the number 29 right here, 63%. This is pretty fine. It's just the distributive property, right? The problem with number 4, and you notice it's A, B, C, or D. It's not a new item type. The problem is setting this up. So we have a rectangle, right, with a length of 5 plus 2x and a width of 10. Okay, so there's your distributive property. And a triangle has a base of 30 inches and a height of, the height of 4 inches, right? So we've got 1/2, right, base times height, 4x minus 10. And I did that 1/2 because it's the area. So I had to apply the formula for area, right? This is length times width, or base times height, however you want to describe it. And this is 1/2 base times height. So not only did I have to remember, because the area for triangle is not on your reference materials, so I had to remember the area formula for both triangle and rectangle. And then I had to realize that they're setting up an equation there. It's equal. Those two are equal. So I'm not solving for either. I'm solving for x. So if they gave it to us like this, I'm sure we would get it, because this is just the distributive property. Obviously, we take 1/2 of 30, that's 15. We distribute it out. The problem is setting it up. So that first one, here's our A, here's our B, here's our C, and here's our D. So Obviously, it looks like we're just guessing, with our answer there kind of taking a little bit from either the B or the D. Now, this type of problem, linear equations and the distributive property, since 2016, has never been asked without explicitly providing the equation. Every single practice STAAR test is always, they might give you a story problem, they're always going to explicitly give you the equation. Obviously, they don't have to anymore. So, we need to, for our instructional implications, we need to find, maybe some previous verbal descriptions if we want to. We need to utilize them, and if we need to, we need to take out the equation explicitly being provided for them. That's going to help them practice the skill, but when they need to apply it in a problem situation, it needs to be something that they're going to have to do a little bit of work to set up the equation. So that's going to be a little bit difficult because a lot of practice problems aren't going to be like that. So, we can just utilize some real world scenarios in which you might have two different items that work. I mean, think of it, you could do like a system of equations if you want to, but you're just going to need to practice the distributive property. That's what this particular TEKS is looking for. And then have them work in pairs. Let them do the work. They can create their own problems without explicit equations. Once again, what are some real-world situations that might have you solve for x if it's on both sides of the equation and it includes the distributive property, and then they can exchange that with their peers. But we need to have students focus on building these equations rather than simply solving them when explicitly provided. All right, 8.9c, we are at 43.5% overall mastery. You could tell we did a little bit better on number 36, a little bit worse on number 14. So we're writing exponential functions when we get it in a real world situation. And we got two different issues here. Number one, they did not give you a percent in number 14, right? They give you your initial, right? So in our y equals a times b to the x, right? This is your a, so that's simple. We're used to that. But we're looking for a percent. We're looking for some type of percent, so we can make it our b, right? Our growth factor or our decay factor, and it's not there. What they have to know is they have to know that this b is going to be, right, year one, so that's 50,400, over the initial. That actually is their percent, and that's what made it difficult. Here, this is just the standard problem we run into. Increases by 4%, right? What do we do with that 4%? Right? A lot of students just chose that 4 because they know that's the percent. We had to correctly translate that into the 1.04. So, the students were not provided the growth factor for the first problem. That made it difficult. Growth factor of 4% had to be translated to 1.04. That was the problem for the second one. So our instructional implications are, we need to have students practice finding growth decay factor when given the initial and the first year amount. I mean, we just need to copy what they did there. And maybe not even calculate it, maybe just represent it, because you notice they didn't actually want them to turn that into a percent. They just wanted them to represent it as an improper fraction if it's growth, right? If it's a decay, it would be a proper fraction. And then, once again, we need to provide that rationale for translating a growth factor into 1 plus the decimal and a decay factor of 1 minus the decimal. Why does a 4% growth equal 1.04? Why can't it just equal 4? Or why can't it equal 0.04 if I want to turn that into a decimal? That's what students need a little bit more understanding of and why it works. And then, give students a percentage, right? A decay of 22%. This is another one that trips us up. It wasn't asked this year, but it's been asked in years in the past. This 22% is subtracted from 1, so then that becomes 78.78, and that really throws kids off because they're looking for 22, and the answer doesn't even include the digits 2 or 2, so that really throws kids off. So just extra practice on doing that, but really focusing on the rationale. Kids need to know why something is true, not just how to find something that's true. For 8.6a, we are looking at 45.5% overall mastery. It's the domain and range, so we're still struggling with domain and range. We struggle with domain and range of linear functions. Now we're struggling with domain and range of quadratic functions. And you see we're about split even, about 47% on this one, 44% on this one. They're both multiple choice, right? Now, they're going to ask, at least on number 11, they're going to ask you questions about the domain. One thing that we can tell kids is that, very, very rarely are we going to be restricting the domain, right? It's the range that's going to be restricted on a quadratic, unless they specifically show you a graph that, it's cut off or something like that. So we could have eliminated some answer choices there. And then this, right, this wasn't a graph, this isn't even an equation. You have to infer this from a table. And, here's our issue right here. Improper fractions, right? The mere fact of just converting those into decimals and then trying to find, right, the peak, you can kind of graph it like that, but you have to convert those into decimals, and that's just a layer of complexity. So, students need to graph at least one problem to correctly identify the range. So you could identify the second one if you convert those into mixed numbers or decimals, right? You can identify where the peak is, right? It's going to be this right here, this 19/4. This one, you do have to graph it. We're not just going to eyeball that. And so there's a little bit of work that needs to be done there, and then the improper fractions obviously made the visual sequencing challenging. So we, once again, just like we do with the linear functions, we need to reinforce the difference between the domain and the range, right? The domain goes side to side. Those are your x, your independent variables. The range goes up and down. Those are your y's. Those are your dependent variables. And domain is rarely limited with the quadratic equations. What we could have done from this table here is once we translated the improper fractions to the mixed numbers or the decimals, we could have sketched a rough parabola, and we could have just figured out that 19/4 even without working out the problem through an actual representation on a graphing calculator. But that's also a good strategy. So we could have students, they're pretty comfortable, most likely, graphing an equation, but are they comfortable plotting discrete points? Because you could still get the shape of the parabola if you plotted those discrete points on that second problem. So these are some different instructional implications that we could use to increase this standard. And we are going to end up with 8.5. See, this is our final one, 49.5. So if you round, it's 50% overall mastery, but it's really 49.5. So it's solving systems of equations, and you could tell we did this one really easily. And you had to do a little bit of work on this one, right? You can multiply that bottom one by 5. To get this into a negative 5y. You could multiply the top one by 2 to get that negative 3x into a negative 6x, right? There's two different options to get there. They both get to the same answer. They're kind of lined up visually like that. What made number 40 so difficult? They just gave it to you in a table. There are no x's and y's, but you have to provide your x's, you have to provide your y's, but look, there's no multiplication. They gave you two 29s, right? And you're looking for website 1. So website 1 is the x. So the website 2, the y's, eliminate themselves. So it's all lined up, but the challenge is it was given to you in a table. It's not given to you as actual equations. So they might not have even recognized that it was a system of equations. So the answer selections for number 40, right, that was our second one that we had the issue with. Once again, indicative of guessing, right? So we had this one a little bit higher, this one a little bit lower, but for the most part, we're right at about that 25%. And it's because we've never asked since 2016 a system of equations by using a table, right? It's either going to be a verbal description, or it's going to, but even then, the verbal descriptions typically have bullet points, so it's kind of clear that you're setting up two different equations, or they just give you the straight equations. We've never done it in a table. So the instructional implications here, we need to have students practice taking systems of equation questions that are maybe even released, translate them into tables, right? Especially tables that don't even necessarily have the x's and y's. There's nothing that says x or y here. So if they can translate from the equations or the verbal descriptions back into the tables, then that gets them in the frame of mind of, okay, so I can get it in all three types, not just verbal descriptions or equations. And then we need to reinforce the qualities that define a system of equations, right? There are two or more equations that share variables to better identify them in real-world situations, because there were no variables given on this second one right here. They just talk about website 1, they talk about website 2, but it never explicitly said X or Y. So you had to infer that we're dealing with two different variables and that they're within the same system. So the recognition of system equations probably was difficult for students. And that is the analysis of the 2023 Algebra 1 STAAR. If you have in need of any further resources, you can check out my website. It's 5minutemath.net.